What's up, everybody, and welcome back. So today I'm working on my English wheel some more. If you watched my last video on the English wheel, I talked about that pipe, my lower anvil needing to have a slot milled into it. So I ended up setting it up on my mill, mounted it directly to the table in the slot, so it's in the middle slot. So my X dimension is true. It's straight that way. Now we're going to find my Y dimension. And the way I'm going to do that is I got a center drill in here. I'm going to raise it up. I'm going to turn the machine on. And then I'm just going to go until I can lightly graze that. And when it just grazes the very top of it, it'll graze the very top. And that should be my center point. And that's where we will drill and put the slot in. This one, it's going to be within, this is not perfect, but it'll be within close enough tolerances of center. Now this is not that critical because I can position it any way I want when I weld it into the English wheel. The part that is going to be critical is when I put the set screw in. When I put the other piece in and the set screw goes in there, that piece will be critical of where that is drilled at, because that's going to align my lower wheel with my upper wheel. All right, so I'm going to get this plugged in and we'll get started. All right, I had to get my safety glasses. So what I'm using to do this is called a center drill. So it's not a normal drill. It's just a center drill for center drilling holes. And then we'll go in and use your bigger drill bit. But I'm going to use that to find my dead center, or my Y, for my Y axis. Okay, I just grazed the top of it. So now I got a little mark in it, right? Right there, little mark. So now I find the center of that, and that will be where we will drill our slot, or drill our hole to start our slot. I'm gonna try and get a little bit closer. All right, that's perfect. So what I did was I tried it again. I just lowered the Z. I brought it down to where I seen it touch, lifted it up just a little bit, and then started running it back and forth and lowering it using my DRO, lowering it 10 thousandths at a time, 2 passes, and I barely touched it. And now there's a much finer, you're not even going to be able to see it, but there is a much finer, much more narrow little spot that will be a lot easier, and I'm just going to eyeball it now. Right about there. That looks pretty much dead nut center to me. So that's good enough. Let's drill a pilot hole. We'll set my Y0 so I know exactly where it's at. And now I'm going to move this. I'm going to move my X up to about, we'll say there. And that'll be my X0. Now, that's where I will drill my pilot hole. You know, before I go any further, I need to find out exactly which bolt I'm going to put in that thing, so I can make sure that my slot is the right diameter for the head, not the bolt. All right, I found my bolt, 1/4 by 20, and my head is 0.391. So first thing I'm going to do is I'm going to drill it with a 5/16 drill bit, and then I'm going to use a 5/16 ball end mill and program it to make my slot for me. So, see how it goes. There we go. Okay, now that we got our hole drilled, I'm going to swap it out for my 5/16 ball end mill, and then I'm going to try and start programming it. I might not have had to even do that hole, but now it gives a place for the ball mill to start. So it'll start there, and then it'll go down and back and forth, and put our slot in there if I can program it correctly. Alright, so I got my tooling swapped out, and just like I set my X and my Y, now I'm going to set my Z0. So, typically just do this with a piece of paper until it touches. Actually, let's move it over. There. That'll be my Z0. It's just dragging there. Okay? So now we set Z0. We're good to go on the DRO. Now we're going to figure out how to program this. So I've only programmed circles. So first off, we go to program. We select our tool. Our tool diameter is 5/16, but this is in decimals, equals 0.3125. So we're going to make it oversized a little bit. We're going to go 0.313. Not going to worry about the length. Tool type, ball end mill, enter. We're going to start at 0, X0, start at Y0, start at Z0. Tool change required, no, hit use. Okay, first one we're going to do is we're going to do a line from let's try go cancel, try rectangle. Yeah, look at that slot. So first arc center will be at 0, 0. Second arc center will be does this go? We need to go back to the DRO. We need to move our X and see if we're going, yeah, we're going negative. So I want to go 4 inches. So go back to program. Our second arc center will be -4 on the, oh shit. Yeah, on the X. And our Y will still be 0. We're beginning, our Z is beginning at 0. we're going to end, this is a 1/4 inch thick, so we're going to go a little bit past that. We're going to go 0.3. Number of passes, let's do 10. Okay, we're going to cut counterclockwise. Slot width, our slot width is 0.390, but I'm going to go 0.391. Give it a little bit extra. Slot length, 0.43910. So let's yeah, that'll be fine. That'll work. That'll be fine. Okay. Use. Z must be above O. So on your Z, you got to hit negative because you're going down. So that's where we need to be. That's where we were messed up there. Okay, use. There's our slot. Okay, so it just finished its first full pass, and it did a really, really nice job. I just didn't program it to go down far enough, so we need to go down a little bit further. And it worked. Because like I said, I oversized the tooling, so my tool width, or my slot width, is a little undersized for this. The reason I did that is because I want this to be a nice clean fit. I don't want it too sloppy. I don't want it too oversized. But you can see like it just doesn't fit in there right now. So what we do is we go back into the tooling and change our tool diameter and bring it back down a little bit, and we can sneak up because the tool will be smaller, and it has to go to the same width of the slot that we put in there, that we programmed in. I hope that makes sense. If not, leave a comment and I'll try and explain it a little bit more. But yeah, so we're going to go back into the program. First off, I'm going to go into my slot and I'm going to change my depth to negative 0.325. Give me another 1/8 inch because it is literally right there. Like there's barely anything. Or we can go clear, negative 0.35. We'll do that. Use. Okay. Now we go up to our tool. We're going to enter into our tool. And see, I did 0.3130. And what's the diameter of a 5/16 end mill? 0.3125. So 0.31. So now we will go, we'll enter this. Oh, we will go 0.3128. We'll try that. We'll go down just a little bit. Use. And now it's ready to run again. And then it'll widen out the slot width will widen out a little bit, just a couple thousandths. And then the slot, it'll go down a little bit further and slot that thing all out. All right. Now it's going to do its thing. It goes down the center and then it goes and does the outsides around. So it's going to take a long time. No reason to re-record it. I'll come back when the slot's all done and the bolt fits in there nice and smooth. All right, I finally got the slot milled out, and I milled it out perfect by taking my time and sneaking up on my dimensions, my width, by decreasing the size of my tool. I was able to get the perfect fitment that I was looking for. Now you can absolutely do this by changing the overall width of the slot too, It's just another option. But check this out. So it's like perfect. The bullhead slides in there, and there's just a very slight drag. So this is going to keep my wheels perfectly aligned when I get it all welded up and centered inside on the frame. And this little bit of drag will eventually wear to where it runs perfectly smooth. Like it goes all the way up and down as it is, and eventually like that's just gonna like smooth itself out and be perfect. So that piece is done. On to the next step, which I believe I gotta clean this out. We'll be starting to assemble this thing. All right, we're ready to start welding it up. I got some stops in here to stop it from going that way. And I got these flipped around, and they're pushing it. So that is pushed against that, stopped against that. So I know that's tight. Now I'm gonna tack weld in 3 spots, and then I'm gonna start welding it around, and then I'll flip it over and weld it the rest of the way. But I'm gonna weld it in spot, and hopefully it goes good. I did bevel this edge on the pipe, so that's got a bevel on it. The cap's got a slight bevel on it, not as much as the pipe, but it's plenty enough to get some good weld penetration in there. Look at that. Brand new filler rod. Filthy. All right, that piece is welded up now. Now I need to let that cool down. And then the next step will be welding. Next step for this part will be welding it into the frame. So this lower anvil is done, all except for my set screw. I don't want to set my set screw until I have it in the frame and get the wheels lined up, because the wheels have to be lined up. That's the most critical part. The wheels have to be lined up, and the set screw is going to keep them in line. So that's going to be a wrap on this video. That's how I built my lower anvil for my English wheel. So until next time, don't forget to hit the like, subscribe, notifications button, and I'll catch you on the next one.